Hello everyone, this is Dr. G. Anita Epsipa, Department of Chemistry, Dr. S.N.S. Rajalakshmi College of Arts and Science, Coimbatore. In this lecture series, we are discussing about the different types of individual dyes. In the first lecture, we discussed about basic dyes. And now in this video, we'll be discussing about direct dyes. Since the word implies can be directly applied without any much modification or else any other after treatment like that. So they are also called as substantive dyes because of their excellent substantivity for cellulosic textile materials like cotton and viscose rayon. They cannot be applied for protein fibers and other synthetics, but they have direct affinity for cotton and viscose rayon. There are three different classification of direct dyes. One is self-leveling, second one is salt controllable, and the third one is temperature controllable dyes. What is the self-leveling dye? Self-leveling dyes are dyes which gets attached to the fiber in a controlled way. That is, they do not need any leveling agent or retarding agent. So the rate of fixation is uniform throughout the dyeing process. This is one of the speciality of direct dyes. Second one is salt controllable dyes. Here in this case of direct dye, the required amount of salt is very much less, which is used for exhaustion and fixation, right? And then temperature controllable. Some of them go for uniform dyeing when the temperature is maintained. So three ways they are more unique. Some of them are self-leveling, uniform dyeing happens. Some of them you can control the amount of salt and then you can go for uniform dyeing, and some of them when you maintain the temperature you can go for uniform dyeing. Now coming to dyeing process, there are two important steps. One is the preparation of dye bath and the other one is the dyeing. Here this direct dye is completely soluble in water, so the dye is dissolved by pasting in small amount of water, and sometimes you need a soda ash, okay, for complete dissolution. So boiling water is added to the paste with constant stirring, and when you go for dyeing like this, you will prepare a stock solution, that is for example 10%. From that you can go for 1%, 2%, 3%, 4%, whatever you need you can go. So stock solutions are usually prepared and then they are appropriately diluted and used. So the dyeing procedure, the dye bath is set with volume required. So the dye bath is set with the required volume of the stock solution of dye, that is 0.5 to 1%, and then soda ash and water are added as per the desired ml ratio. What is the ml ratio? Usually this ml ratio is fixed as 1 is to 20 for small lots and for 1 is to 10 for larger lots. So what is this 1 is to 10, 1 is to 20? If you take 1 gram of fabric, you have to take 10 times of water. If you take 1 gram of fabric, you have to take 20 types of water, so that it is called as material to liquor ratio. Okay, this has to be calculated and added so that the proper percentage of shade can be obtained. So when you want to repeat the same thing for different batches, this has to be maintained very accurately. Then the process material is entered into the dye bath at 40 degrees Celsius and the dyeing is carried out for 15 to 20 minutes. So here you see it is 1 is to 4. That means 1 gram of fabric, 4 ml of water, right? 400 ml of water. And then here the required amount of common salt is added even in a number of installments at intervals of 10 to 15 minutes for proper fixation and exhaustion throughout the dyeing process. Here you see this is the tumbler dyeing water bath we use for dyeing. The salt content, that is the amount of salt, varies between 5 to 10% on weight of material from light to heavy shades. For lighter shades we can go for 5% of salt. For heavier shades we go for 20% of salt. So the temperature of the dye bath is slowly raised to boil and it is continued as this temperature for the period of 45 to 60 minutes, and then it is cooled for to 15 to 20 minutes for better exhaustion. So this is how the dyeing process takes place. The goods are then removed from the dye solution, squeezed and dried, and after treated if needed, by some dye fixing agents after precise drying stage. When some of the dyes, direct dyes, they have very poor drying and washing fastness. To improve the fastness properties, they can be taken for some after treatment. So when can you decrease the solubility? When you increase the molecular weight of the dye, you can decrease the solubility after dyeing. If the solubility decreases, you automatically improve the washing fastness. So here there are certain attempts which will help us to increase the molecular weight of dye. Okay, the first one is treatment with copper salts after drying. Okay, then second one is treatment with chromium compounds, treatment with formaldehyde, treatment with cationic dye fixing agent, chopping with basic dyes. In the previous video also I have told you about how direct dye and basic dye can be dyed by using mordants. Okay, diazotization and development of direct dyes. So these are all the after treatment methods which can be applied on direct dyes to improve their washing fastness. Thank you.